Greetings to 100% here. Let me introduce about myself. My name is Mr. A. Jasmine Anthony Raj, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. Today, we are going to see about the topic curse of and dimensionality from the subject and data science. So here, if you want to know about this and topic, so we can able to start with the topic. So here, if we want to know first of all, we want to know the meaning of an curse of an dimensionality. So it is nothing but it refers to the problem that arises and when analyzing and modeling a data in a high dimensional space. So here normally this information will be, this concept will be the curse of an dimensionality will be able to arise a problem when we are analyzing or modeling the data in a high dimensionality space. So here, that is, if you want to know better, I can able to give you a simple example. So here explanations of a data with many features are in variables. So this problem will be arrive when we are using many features of data we are using with the features or with variables. So here, if you want to know about and further, so now as the number of dimensionalities increases, the data becomes increasingly sparse. So here, if we are using a large dimension, so then automatically the dimensionalities also will be increasing with the sparse. So in order to making it difficult in a machine learning algorithm, we can able to find a meaningful patterns. So the term was introduced. So this term was defined and explained by the persons and Richard Bellman. So why this high dimensionality is a problem for a data sparsity means. So here, if we can able to go with the concept that when the dimensionality is increases, automatically the data points will spread out. So here we want to check the availabilities of a data is being insufficient to represent the space. So here, so if we are representing an insufficient space, we can able to move the model struggle to generalize. So here, if we are going with the concept that when the data became insufficient, it will represent the space we cannot able to have enough information. So examples we can able to consider 10 points or dense in 2D but an extremely sparse in 100D. So here, if we cannot able to have used those 10 points in 2D, but we can extremely sparse it in 100D. That is the dimensionalities. So next one, we can able to check with the distance measures for loose meaning. So here, how can we able to use a distance based algorithm means here we have a KNN, and K means are the DBSCAN, so which is really on an similarities. So if you want to use to calculate the distance based algorithm, we can able to use different types of defined informations or term words. So here, next one, in an I dimensions, distance between points became almost equal, hard to distinguish near and far points. So if you are using high dimensions, so we have difficulties we have we cannot able to have to distinguish. How can we able to have to distinguish between near and far more points? So next one, so here increased computational cost. So how can we able to see with the next topic, that is an increased computational cost. So here we have more features for more calculations. So if we have a more number of features in our data, then automatically we can able to have a more number of calculations to be performed on those informations. So next one, so training becomes slower and memory intensive. So here, if we are moving with the large number of data for a computational process, then we can able to automatically we can able to slow and memory intensive. Next one, algorithm scale poorly. So if we are going for a large number of data, we can able to move the problem of having an algorithm will scales poorly. Next one, outfittings. So what is meant by outfittings? So here it is nothing but a model learns a noise instead of patterns. So here, if we are having an n number of models, it will be smooth when we having a number of patterns, but if it is more, it can able to have to give the noise. So here we need to move with the next topic, that is too many features compared to the number of observations. So poor performance on an unseen data can be able to seen. So it represents the poor performance. Next one, we can able to move that visualizations become difficult. So here, if we have a large number of data, so we cannot able to have to give the concept on a visualization process. By having the concept of an approaches of doing and visualization, it became difficult. So next one, so human can visualize only up to 3 dimensions. So high dimensional data in hard to interpret. So we have a minimum limitations of an 3 dimensions. So only the human have a capacity of visualizations only up to 3 dimensions. So when we have a high dimensions, so the data doesn't have to be hard. It will be very hard to be interpreted. So next one, impact on a data science algorithm. What is mean by impact on a data science algorithm means? So here we can able to have to divide the terms. That is an algorithm type. It is an efficient. Next one, we can able to check with the k nearer neighbor algorithm. So it can able to measure the distance between an unreliable data or distance. So here next one, and clustering. That means clustering means we can also tell as an k means. So here k means is used to have a poor cluster formations. Next one, and regressions models. It is used for an multi collinearity overfittings. And next one, so if you want to know about classifications, it can able to have a reduced accuracy. So by using this and classifications, we can able to reduce the accuracy process. So next one, density estimations means, so by using this we can able to become an ineffective. Next one, if you want to see about an examples, I can give you the examples on a concept of an when we are recognizing an image. So we can able to have an 100 into 100 and grayscale image which has a dimensions of an 10,000 dimensions. So if you have a calculations of 100 into 100 grayscale image, so the final output will be then 10,000 dimensions will be occurring. So next one, if we have a huge feature space, so then we can able to go with the curse of an dimensionality. So also it is used to require an dimensionality reductions before and modeling. When we are going for a modeling, so before going for the process modeling process, we need to reduce the dimensionality. So next one, so by seeing these informations, how can we able to overcome the curse of a dimensionality means? So dimensionality reductions will be occurring with the concept of an principal component analysis and an linear dimensional dominant and analysis, and an auto coder will be implemented. So by using these informations, where we can able to check the concept. Thank you one and all. Let me meet in another session.